Today's lesson is on the measures of central tendency. When we get our numerical data, like yesterday, we want to display it sometimes. However, other times, we want to know a single number that's representative of the data as a whole. We call these types of numbers measures of central tendency, because as you guessed, we usually will find the central number of the data, or in other words, the number in the middle. Now this number might not actually be a number in your data set. It just describes where the middle of your data set is. The two most common measures of central tendency are the mean and the median. The mean is simply the average. You find it by adding all the numbers that you have in your data set and dividing that by the total number of data values you had. The mean is exactly the middle of your data set. The first example says, using the data from the warm-up, answer the following questions. Find the mean and median for this data set. Now we were told how many cars are in our data set. Go back and find that number and tell me what it is. The next thing we need to know is what are our actual numbers in the data set. So what's the first one? The first car was driving at 29 miles per hour. The next speed we have is 33. How many cars were driving at that speed? If you look at the table, there were 2, so we're going to write 33 down twice. And keep going with me. We have 4 cars that were going a speed of 34, so I'm going to write 34 down 4 times. Then we had 5 cars going 35 miles per hour, so 5 35s. 4, 5. All right, we had 36. There's 3 of those, so write down 3 36s. Then we had 2 38s, 2 39s, and one really fast person going 54. When I add all those numbers up, I should have 20 numbers there. Let's start by finding the mean. In your calculator right now, go ahead and type in all the numbers, adding them. So 29 plus 33 plus 33 plus 34 and so on, and find the total when you add all the numbers. You should have gotten 722 as your total. To find our mean, we then take that and we divide that by the total number of cars we had, which is 20. And we get our mean, or our average speed, to be 36.1 miles per hour. Next, we're going to find the median. To do that, I'm going to start by crossing off the first data set value and the last one at the same time. So 29 and 54, cross them off. 33, 39, cross them off. 33, 39 again. Keep going. As a note, before I can do this, you have to make sure your data numbers are in order. Alright, now I get down to 2 numbers left, and I don't want to cross them both off. What I'm going to do is I'm going to find the average of those 2. So that's going to give me the median. Well, it just so happens that these are the same numbers. So when I add 35 plus 35, and divide that by 2, I get 35 again. So my median is 35. If you have an odd number of data in your set, for example, if I only had 19 numbers, then that number in the middle is your answer. You don't have to find the average there. Okay, so our mean was 36.1 miles per hour and our median is 35. Part B says the speed limit along this part of the highway is 35 miles per hour. So I'm going to underline that. That's important to know. Based on your result from Part A, is it fair to make the conclusion that the average driver does speed on this roadway? Well, we had two pieces of information. We had a mean, which was 36.1, and we had a median, which is 35. Because we had one number, that 54, that was so far away from the other data set, we want to go with the median. That 54 is what we're going to learn to be called an outlier. And whenever there's an outlier, the median is your best indication of your data value. So to answer the question, if the speed limit is 35 and I look at the average speed using the median, it is 35. So my answer is no. The median is 35. And a better indicator of the average because better indicator of the average because of the outlier. Of 54.